Okay, good morning or afternoon, whenever you're watching this. We are on week 2, geometry, 4.2, transversals and parallel lines. Okay, so this lesson is going to have a lot of vocabulary words. As you guys can see right here, there's a bunch of them: corresponding angles, same side interior angles, alternative interior angles, alternative exterior angles, and there's a couple postulates. Now, the word postulates and theorems, these are kind of rules. They've been proven by, there's a variety of different explanations for why they work. For the sake of this class and what we're doing, I'm just going to have you memorize these as rules. And you're going to use these postulates in order to figure out the answers to a lot of these problems. Um, Unfortunately, because we only have 5 weeks, we're not going to get into too much how they're derived. However, throughout this lesson, you will see how a lot of these theorems work with each other, and the fact that one does not work unless the other ones are working at the same time. Now, in order for any of these definitions to make sense, you guys need to know what transversal and parallel lines are. So, oops, sorry about that. Okay. Now, parallel lines are two lines that are never going to touch. This is a basic definition that you should know, but if you don't, go ahead and write it down. I want you to write down all these definitions, actually. So before we get started, go ahead and pause the video and take down these notes. Screenshot them, do whatever you need to make sure that you have your notes written down so you can turn them in for points this week. All right, okay? So I'm going to keep going. Now, these are called parallel lines, right? What they mean is they're two lines that are never going to touch because they're headed in the same direction and they have the same slope. Now, we're not going to talk too much about slope in this video. That's going to be for another video that we're going to go into detail a lot. However, for now, just know that these two lines are parallel lines, and you're going to see this a lot throughout this video. Then we have another vocabulary word that I don't have written on here, but you're going to see a lot. There's going to be another line like this. This line right here is called the transversal. Okay, I'm going to make reference to a transversal a lot. It's a line that cuts in between two parallel lines. However, this line, the transversal, is not necessarily perpendicular. That means that it cuts it at a certain angle, and we don't know what the angle is yet, right? But we know that because it cuts the parallel lines, it's going to make a couple of different angles. I'm going to label these angles as follows: 1, 2, 3, 4, 5, 6, 7, and 8. You're going to see this a lot, right? Now, this formation means that because the transversal cut the lines and the lines are parallel, certain angles were made and certain rules were formed. And that's what all these other vocabulary words are making reference to, okay? So just know that's a transversal. These two are parallel lines. And all these other vocabulary words are going to have to do with the angles that they make. So why don't we take a look at some of these angles, right? We have the first one, which are corresponding angles. Now, the definition says they lie on the same side of the transversal and on the same side of the intersected lines. So those are a lot of rules. It might be a little easier if I had a bunch of visuals to show you. So we're going to move on to the next slide. Okay, this is the same. The top part is where everything is based off of. Once again, that is the transversal. And these are the parallel lines. Okay, and those are the angles that they make. Now, as of right now, we don't know exactly how many degrees each one of those angles is, but because of the rules from the last slide, we know a couple things about them. Now, I'm going to circle the angles in each section. Now, if you notice, there's a section for each type of angle, right? Now, we have corresponding angles, right? The very first one right here, we're right here. Corresponding angles, I'm going to circle all the angles that are corresponding to angle 1. We're going to start here, all right? Now, the only thing we know is that there is a transversal cutting this, and there's two parallel lines, which means that there's a bunch of angles that are corresponding to this angle. Now, the rule, if we go back, says that corresponding angles have to lie on the same side of the transversal and on the same side of the intersecting lines. Okay, so what exactly does that mean? Well, same side of the transversal means that they're on the same side of the transversal. They're either going to be on the left side of the transversal or the right side. If you notice number one, that's circled, it's on the left side of the transversal, which means that an angle is going to be correspond to it if and only if, right, there's angle, if it's on the left side of the transversal. So let's look at all the angles on the left side. There's angle 4, 5, and 8. Now, the second rule will help determine which other angle is corresponding. Now, it says that it has to be on the same side of the intersected lines as well, right? Now, what they mean by that is, let's take a look at this first parallel line right here. We're gonna call this line, why don't we call it, I don't know, D, line D, and let's call this line B, right? D and B. Remember, these are lines that I'm talking about. So angle 1 is to the left side of the transversal, and it's also on the top of line D. If you notice that, you notice it's in that top left-hand corner, right? We need another angle that's going to be roughly around the same position, but on line B. So which one of the four angles, 5, 6, 7, or 8, is on the top left-hand corner? Well, there's only one, angle 5. So we know that measure angle 1 corresponds to measure angle 5. And the rule says if they're corresponding, they're the same. That means they equal each other, okay? Whatever 1 is, whatever degree it is, it can be 120, it can be 50, it doesn't matter what it is. The rule says because they're in the same position but in different parallel lines and on the same side of the transversal, they equal each other. So measure angle 1 equals measure angle 5, okay? Now, this equivalence is called corresponding angles, and you're going to have to talk. For example, a problem might be like, which angles are corresponding? You're going to have to respond, measure angle 1 and measure angle 5 are corresponding angles because they're in the same position, but in different lines, right? That means that they equal each other, right? By the way, there's an equal sign. I know I did it kind of weird there. Okay, now, is there another corresponding angle? This time I'm going to do it in squares. Well, yeah, let's go. Let's see if there's what angle corresponds to angle 2. Remember, angle 2 looks like it's in the top right hand position. It's on the right side of the transversal, and it's on the top of angle of line D. So we need to find another angle that is in the same position, but in line B, the top half of line B, and on the right of the transversal. There's only one angle that meets all those criteria, and that is 6, which means measure angle 2 is equal to measure angle 6 because they are corresponding angles. Now, I seem to have run out of room here, but if you guys notice, measure angle 4 is also in the same position as measure angle 8. They're both on the lower half of line D and on the left side of the transversal, right? So I'm going to go ahead and let's do a triangle, right? 4, 8 is in the same position, just in a different line, which means I'm going to write it up here. Measure angle 4 is equal to measure angle 8. And that leaves only one pair that we haven't said. Measure angle 3 and measure angle 7. Okay, do you guys think that measure angle 3 and measure angle 7 are considered corresponding angles? Do you guys think they're going to be equal to each other? Well, the answer is yes. Measure angle 3, right, is equal to measure angle 7. When I put numbers on these, this will make a lot more sense, right? And it'll make sense because we're going to be dealing with lines, and lines are supplementary, and that's something that we learned last week, and we're going to apply it this week too, okay? In the meantime, why don't we move on to the next rule, right? Same side, interior angles. Okay, now, same side just means same side. Remember how I said like the left side of the transversal, right side of the transversal, right? That's what I'm referring to, the left side or the right side. If they're on the same, that means that the two angles I'm talking about, right, are either both going to be on the left side of the transversal or they're going to be on the right side of the transversal, okay? And then the second part of that is interior angles. Now, I want you guys to take a look at this, right? This is what we call the interior, right? The interior, all the angles on the inside of the two parallel lines. We're talking about angles 4, 3, 5, 6. Those are all interior angles because they're on the inside of the parallel lines. However, what if we're talking about exterior angles, right? This one right here and this one down here. Measure angles 1 and 2 are exterior, and measure angles 8 and 7 are also exterior. I know my handwriting is terrible. Anyways, so if they're considered exterior, that means that they're on the outside of the parallel lines. They're either on the top half of the parallel lines or on the bottom half of the parallel lines. 1 and 2, 8 and 7 are exterior. 4, 3, 5, and 6 are interior. Okay, let's go back to this, right? We're now on this one. Let's circle the ones that are same side interior angles, right? So remember, there's only 4 that are inside, 3, 4, 5, and 6. Same side interior angles, right? We're talking about 4 and we're talking about 5. Now let's go ahead and look at the rule, right? The rule says they lie on the same side and between intersected lines. What you need to know about same side interior angles, right? Let's look at the same side interior postulate right here. If 2 parallel lines are cut by a transversal, that's what we have, then the points on the same side of the interior angles are supplementary. What that means is measure angle 4 and 5 don't equal each other. Don't think that. If they're on the same side like right now, they complete each other, which means measure angle 4 plus measure angle 5 have to equal 180 because same side interior angles are supplementary. There's that word from last week. So remember, supplementary means 2 angles that add up to equal 180. Well, same side interior angles, like angles 4 and 5, add up to equal 180. And this is really important. You guys need to remember this because you're going to use it to solve a lot of problems. All right. Can we name 2 more angles that are same side interior? Well, if 4 and 5 are to the left side of the transversal, 3 and 6 are to the right side of the transversal. Since they're both on the right side, they're considered same side. And since they're interior, they're considered same side interior angles, which means that we can apply this rule. Measure angle 3 plus measure angle 6 has to equal how much? You got it, 180 degrees. Okay, that's the second one. Now let's look at alternate interior angles. Now remember, the word here, the key word here is alternate. Alternate means they're on the opposite sides of the transversal, right? So why don't we look at angles that are on the opposite side of the transversal from each other, right? 4 and now, okay. Before we get started, I need to make a distinction here. Alternate interior angles, and the next one is alternate exterior angles, which means we're still dealing with the numbers on the inside. Right now, I'm only focused on angles 3, 4, 5, and 6, right? Because they're all inside, right? These are all interior, right? Since they're all interior, I need to find the ones that are alternate. They're on alternate sides. One angle is going to be on the left side of the transversal, and the other one's going to be on the right side of the transversal, and they have to be inside. Now, I don't just mean opposites like 4 and 3. 4 and 3 are not alternate interior angles, right? 4 and 3 are more like angles that add up to a straight angle, like last week. They add up to equal 180 degrees. They make up a line. That's a whole nother thing. We're talking about angles like angles 4 and angle 6. Angle 4 and angle 6 are what we would consider alternate interior angles. They're on the opposite sides of each other, right? Opposite sides, and they're on the inside of the parallel lines, opposite sides of the transversal. So what does that mean? Measure angle 4, right, is going to be equal to measure angle 6. Okay, that means that if measure angle 4 is 50 degrees, measure angle 6 has to equal 50 degrees. If measure angle 4 is 170 degrees or something ridiculous, measure angle 6 has to be the same thing because they're alternate interior. Likewise, there's another pair of alternate interior angles. Can you guys name them? Well, I hope you said measure angle 3 and measure angle 5, okay? Because those are the other ones. Measure angle 3 is going to also equal to measure angle 5. And why does this make sense? Well, this makes sense because, again, I'll explain this a little bit more in detail once we have the numbers. This is just a theory, okay? These are something you're going to have to memorize, but I'll explain why these equal each other. Now, alternate exterior angles are going to equal each other as well, okay? Now, again, right here it says alternate exterior angles lie on opposite sides of the transversal and outside the intersecting lines. Remember, there are the exterior angles. We're talking about 1 and 2, 8 and 7. We're also not talking about the ones that are right next to each other. Again, the angles that are right next to each other, like 1 and 2, those are supplementary. Angle 1 plus angle 2 would equal 180 degrees, but that's not what we're talking about here. We're talking about alternate exterior angles, exterior. What that means is there's going to be a pair of angles that are going to be equal to each other, and they have to be opposites, kind of like the interior angles, right? An example of alternate interior angles is angle 1, and on the opposite side of that is going to be either 2 or 7. Now, we established it's not 2, which means it can only be 7. Now, measure angle 1 is going to be, equal to measure angle 7. Just like measure angle 2 is going to be equal to which one? That's right, measure angle 8. Okay. Okay. Now, why don't we do the same thing? Why don't we use all these postulates, but this time let's add numbers, right? Okay, question. Find the missing angles. Assume the two lines are parallel and line L is a transversal. Okay, so why don't we first figure out what's going on here? Why don't I just label this L? And I'm supposed to find all the missing angles. Now, if you notice, there's a lot going on here, right? Why don't we just list all the angles that we do know, right? Like measure angle 1, it says here in the given, and this is like the problem that's going to be given. Measure angle 1 is 120 degrees. We know that because they just told us. It's right here, right? Okay, cool. What's measure angle 2? Because we need to find out which angle. We need to find out all the angles. So we have 8 angles to figure out using these rules. Do we know what measure angle 2 is? No. They don't say, all right? That means we need to figure it out. 2, 3, and 4. So I'm going to just leave a space here because we need to figure out 2, 3, and 4. We know that measure angle 6, also 5, I guess, because we don't have anything for 5. But we do have something for measure angle 6. It says it's 60 degrees. Okay, that's going to be important. And of course, measure angle 7 and measure angle 8. Okay, how can we figure this out if we only know 2 angles? Well, we're going to use all of our rules, okay? Because in the given, it says we assume that 2 lines are parallel and line L is a transversal, which means since these 2 are parallel, these are interior. This is exterior. These 2 are going to be exterior angles. And we know that there's going to be a couple angles that are corresponding. Let's start with corresponding angles, all right? Which angles correspond to each other? Because remember, corresponding angles equal one another. Let's go back. Corresponding angles, it looks like 1 and 5 are an example of corresponding angles. Now, we know what measure angle 1 is. If measure angle 1 is 120, and we know that measure angle 1 corresponds to position number 5 here, that means they're going to be the same, which means if we know what measure angle 1 is, we know that measure angle 5 is the same thing because they're corresponding angles. So measure angle 5 is 120. Hey, I didn't even have to do any math. I just had to figure out which rule went with which angle, right? Okay, cool. But they're not all corresponding. I'm going to have to use different ones, all right? I still need to, I don't know what 2 is. Well, I do and I don't. Let me introduce something that I kind of skipped over, right? Let's see. There's a postulate, there's this idea that we should be able to sum up 2 angles as long as they're next to each other. So let me redraw this. This is measure angle 1. and this is measure angle 2. Does this look familiar to you guys? It should, because this was what we did last week. And these two angles, right, are supplementary. How do I know this? Because the lines are they're parallel lines. And remember, a line is just 180 degrees, which means that measure angle 1 plus measure angle 2 is equal to 180. Now we know that measure angle 1 is 120 degrees. And hopefully this should look like the kind of problem you were doing last week. All you have to do now is subtract 120 from both sides and you have your answer. So measure angle 2 is equal to, hey, 180 minus 120 is 60 degrees. That's interesting. Measure angle 6 is 60 degrees. So look at that. Okay, so I used last week's lesson to solve it. But if you remember, if you're like, okay, but Mr. Palacios, if we knew what measure angle 6 was, isn't measure angle 6 corresponding to measure angle 2? Couldn't we have just said it was the same, kind of like you did with measure angle 1 and 5? The answer to that is yes. Not only are measure angle 1 and 2 supplementary, and we can use an equation to figure out that it's 60, we've just proven that it's 60. We didn't even have to do all that, because if you knew the rule for corresponding angles, you could have just been like, well, measure angle 6 is corresponding to measure angle 2, and if measure angle 6 is 60, measure angle 2 has to be the same thing, which is 60. So as you can see, there's multiple ways for you guys to get the right answer. I'm looking forward to seeing what ways you guys use these. I do want to know what method you use to figure it out. Remember, there's multiple right answers, so make sure to show your work and make sure to tell me specifically if they're corresponding, if they're supplementary, how you figured out. That's what I'm going to be grading you on, okay? All right, now, what about the rest of them? Sure, corresponding angles are cool, but measure angle 4 and 8 are corresponding, and I don't know what either of them are. What about measure angle 3 and measure angle 7? I don't know what either of them are either. So if I don't know what either of them are, I can't use corresponding angles, right? Because I don't know what it is. But maybe I can use same side interior angles, right? We know that according to same side interior angles, we know that same side interior angles would be like measure angle 4 and measure angle 5. And we happen to know what measure angle 5 is. Now the rule for same side interior angles is that measure angle 4, right, plus measure angle 5 is equal to 180. Because once again, same side interior angles are supplementary according to the rules, right? Right? 4 and 5, that's where I got that from. Okay, but you might be thinking, well, we don't know what measure angle 5 is. Well, actually we do. We figured out. Remember, it was corresponding to measure angle 1, which means that we know measure angle 5 is 120. Hey, didn't we already do this? Yeah, it looks a lot like what we did here, right? I'm just doing it again, but with different kinds of angles. And you'll find that there are lots of shortcuts to these lessons, okay? And I encourage you guys to find them, because yes, it's important for you to know all of these, but the more shortcuts you guys can figure out, the easier this might be for you, right? And I'm not saying cheat or anything. I'm just saying that I want you guys to find the correct answer in as easiest way as possible. If that means that you guys, if the formula is easier for you to do, right, do the formula. If memorizing the rules and applying the rules is easier for you to do that. If you want to pass the quiz and the test and all that stuff, it might be best to learn how to do all of it, right? Because that way you get full credit on everything, right? So far, we figured out the measure angle 4 was 60 degrees. So if measure angle 4 equals 60 degrees, measure angle 5 equals 120. Do you guys see a pattern here? I hope you guys are seeing a pattern. What are the only two angles I seem to be getting? Hopefully the answer you said was 60 and 120, and they seem to be like in alternating patterns, right? That's on purpose, guys. All these are working together to give you that. Let's look at how to find measure angle 3. Well, I could do the same side interior angles, right? I know that measure angle 6 plus measure angle 3 is going to equal 180, but that's going to look a lot like this. I'm just going to change the way it looks, right? Measure angle 3 plus measure angle 6 equals 180. Measure angle 6 is 60 plus measure angle 3 equals 180. Subtract 60. Subtract 60. Hey, look at that. Measure angle 3 equals 120, kind of like the other ones. Wow. It's almost as if they're all going to be this. Okay, measure angle 7. We know that measure angle 6 and measure angle 7 lie on the same line. What do I mean by that? Look, that's an angle. That's 180 because it's a line. We know that if we add 60 to measure angle 7, we're going to get 180. And we know that 60 minus 180 equals 120. This one's going to be 120. I don't even have to do the math anymore because I know I'm following the pattern of the rules. Or I could also have said exterior angles. Remember those? Measure angle 1 is 120. Measure angle 7 is 120. And guess what? Measure angle 1 and measure angle 7 are alternate exterior angles. And the rule for alternate exterior angles was that they what? They equal each other. I didn't even have to do the math. I could have just used the rule. Just like 2 and 8. They equal each other. Right? How do I know which one is which? Well, we know 2 is 60, so measure angle 8 has to be 60. And I've done it. It looks like I've gotten all of them. And my answers were 120 and 60 the entire time. Look at that. Hopefully this isn't too bad, right? I hope it's not, because this is the easy version of the problems. But you are going to have to do a couple other things. For example, what if I give you a blank one like this? And I ask you, hey, can you name the postulates involved? Let's look at these scenarios right here. For question number 1 right here, if measure angle 1 is 120, then according to what postulate would make measure angle 2 60 degrees? Well, I know I didn't really list the postulate for here, but remember how here we said measure angle 1 was 120, and that means that measure angle 1 and measure angle 2 are supplementary. That is called the angles addition postulate. What that's trying to say is that if two angles are next to each other and they make a line, like measure angles 1 and measure angles 2 do, they're going to add together. And they're going to be supplementary. You might be thinking, well, that wasn't what the question was asking you. The question said if this was 120, right? What postulate would make this 60? Well, if you notice, if this is 60, if 2 is 60 and 1 is 120, if we add those together, we get 180. So that was intentional. Again, this is angles, the angle addition postulate. So it just means that we can add those two angles together and they're going to equal 180. They're supplementary, right? It's another name. I know a lot of names, but make sure you have them in your notes. All right. Let's look at the next question. Let's look at question number 2. What postulate says that angle, whoops, I was supposed to say angle. Angles 1 and angle 6 are equal to each other. Hey, look at that. Angle 1 and angle 6. Well, that looks familiar, right? I hope so. These are what kind of angles? Let's go back. Nope, not there. Well, these are different, but 1 and 5 were corresponding. 1 and 6 are still corresponding. But if you notice, it's a different angle. It's not 5 anymore, it's 6. That's because the number or whatever we label the angle doesn't matter. I could label it 6. I could label it angle P. I could label it X. I can label it whatever I want. The important thing about corresponding angles is the position that they're in. They're in the same position, different parallel line, which means that these are corresponding angles. Angles 1 and angle 6 are corresponding to to each other, right? And if they're corresponding, measure angle 1 is going to be equal to measure angle 6, and measure angle 1 is 120 degrees, which means measure angle 6 is also 120 degrees. Okay, let's look at measure angle 3. According to alternate interior angles theorem, angles 4 and 5 are what? Well, alternate interior. We're looking at 4, we're looking at 5. I don't know what 4 and 5 is. Well, I mean, I do know. I can figure it out. But that's not what they're asking. They're not asking like what angle it is. They're just asking, hey, according to alternate interior angles, what would 4 and 5 be? Well, they would be equal to each other because alternate interior angles say that measure angles that are alternate interior equal one another. Well, you might be thinking, okay, mister, I don't believe you. I don't know why you wouldn't, but let's say you were thinking that. What can we do to prove that? Well, I want you to take a look at measure angle 2. I know I didn't explain this last time, but 2 and 4 have something in common. They're what we call vertical angles. Now, I know I haven't covered this, but vertical angles are angles that are opposites to each other. They're diagonal to each other in terms of position. They're across from each other, and 2 and 4 are an example of those. 1 and 3 are example of vertical angles. 6 and 7 are example of vertical angles, and 8 and 5 are examples of vertical angles. Vertical angles are angles that are diagonal to each other, and they equal each other. Which means if measure angle 2 is a vertical angle to measure angle 4, they equal each other. That means that measure angle 2 is 60, measure angle 4 is also 60. Well, how can I prove that? Well, measure angle 1 and measure angle 4 are on the line, right? And a line is 180 degrees. And if I were to add 120 and 60, I get 180 degrees. Which means that I've just proven that measure angle 4 really is 60 degrees. And I use the rule for vertical angles as a shortcut, okay? Okay, that's why it's important for you to be able to prove these, and these are done in proofs. Unfortunately, I don't think we have that much time to do proofs. If we had more time in the class, I would totally do it, but 5 weeks is kind of cutting it short. So we're gonna go through and you do problems like this, okay? Now, number 4, according to same side interior angles, angle 6 plus angle 5, right, equal how many degrees? Okay, there's a mistake on this one. I didn't realize I was supposed to name it something else, right? Okay, why don't we change the question, right? Let's go ahead and don't do that. The question I'm going to give you is going to be a verbal question, okay? According to alternate exterior angles, if measure angle 1 is 120 degrees, how much is measure angle 7? Now, remember, we're talking about alternate exterior angles, which means that measure angle 1 is going to be what to measure angle 7? Alternate exterior angle says that they're going to be equal. So if measure angle 1 is 120 degrees, measure angle 7 has to be the same thing, 120 degrees. Okay, good. We're on the last section. Bear with me, guys. We're almost done. All right, more complicated postulate problems. Now, if you notice here, I just added an extra level of difficulty. I have still labeled them the same, but this time I've included variables that you're gonna have to set equal to each other, and you're gonna have to use every trick you can find to find the answers to these, right? Okay, now again, there's multiple ways of solving this. You just have to tell me which method you use, and I will give you credit, right? Let's say you say that you use corresponding angles to figure out 1 and 6, right? And someone else says that they figured out 6 because of the addition postulate, right? They're both technically correct. I just want to know which one you use, okay? I want to make sure that these definitions are getting through. Okay, the first one where it says find measure angle 1, right? We know that measure angle 1 and measure angle 3 are vertical. We also know that measure angle 3 and measure angle 7 are corresponding. So in a really weird roundabout way, I know what measure angle 1 is. All right, follow me here. All right, measure angle 7, we know, is 150 degrees. We know that measure angle 7 and measure angle 3, because they're in the same position, different lines are going to be corresponding, which means that measure angle 3 is 150 degrees. And look, I did ask what measure angle 3 is, right? So why don't I put that? Measure angle 3 is 150 degrees. And I know this because they're corresponding. All right, so 150 degrees, comma, corresponding angles. Okay, but I was trying to figure out what measure angle 1 was. Well, do you remember, right, when I said over here about vertical angles? Vertical angles are the ones that are diagonal to each other. That means 3 and a 1 are vertical angles, and vertical angles are, if you remember correctly, equal to each other. So measure angle 1 also equals 150 degrees. I know this because of vertical angles. Now, I have a question. Sure, they're vertical angles, and I kind of understand how you did that. But is that the only way to get the answer? No, measure angle 1 and measure angle 7 have a direct relationship. What's the relationship that they have? 1 and 7 are, what were they? What were they called, guys? They're called alternate exterior angles, and they happen to be equal to each other. Is measure angle 1 and measure angle 7 equal to each other from what we figured out? Yes. Yes, they are. So there's two justifications for this. You could have used either or. All right, I would have accepted either or. Ideally, I would have liked for you to know both of them. If you know both of them, you should always write them down too. Okay, we still got to figure out what measure angle 2 is. Now, I could say that measure angle 2 and measure angle 4 are vertical angles, right? 2 and 4, if we know that measure angle 4 is 30 degrees because of the given, right? We know that it's 30, and we know that they're vertical angles. We also know that measure angle 2 and measure angle 1 are right next to each other. They're adjacent, right? They're right next to each other, and they make up a line, which means that measure angle 1 plus measure angle 2 equals 180, and 150 minus 180 equals 30, right? There's that equation we can do. Why don't I write that up here? We know that they're going to be supplementary due to addition postulate. We know that measure angle 1 is 150. We're trying to figure out what measure angle 2 is. We know they're supplementary, so all I have to do is really subtract 150. Measure angle 2 is, hey, look at that, it's 30. Kind of like the vertical angles we figured out, right? I hope so. I'm just going to write addition postulate, right? I can also write that they're supplementary angles. So as you can see, there's a bunch of different ways I could have figured that out. All right, what about measure angle 6? How can we figure out what measure angle 6 is? Well, there's a bunch of ways. There's some ways that are more complicated than others, right? We know that measure angle 4 and 6 are what? They're same side interior angles. I know, that's what you were thinking, but they are. They're same side interior angles, and the rule for them is that same side interior angles add up to equal 180. Well, we kind of already know what happens if you take away 30 from 180, you get 150, which means that 160 is 150. Measure angle 6, I mean. Now, I know this because I could say corresponding angles. I could say corresponding angles because measure angle 1 and 6 are the same. I could say same side interior angles. right? I could also use the addition postulate. If I wanted to be more complicated, let's say I didn't have any of this, and let's say I was forced to do one of these only. Let's say I was forced to do the hardest version of this, right? For measure angle 6. Now, let's say I was forced to use measure angle 5 to figure out what measure angle 6 is. Now, I know you guys are avoiding measure angle 5 because measure angle 5 is, well, it's got an x in it. It's got a variable in it, right? So what do we know about measure angle 6 and measure angle 5? Well, measure angle 6 plus measure angle 5 are going to equal 180. They're supplementary because they make a line together, okay? We don't know what measure angle 6 is, but we know that measure angle 5 is 5x. Okay. So there's a lot of unknowns here. Can I actually do this? Well, not really. The measure angle 6 in this case, because we don't know what it is, it acts like another variable, and we have 2 variables in this case, which means we can't actually use the addition postulate. But we know that measure angle 4 is 30, and we know that measure angle 5 has a relationship with measure angle 4. It's called alternate interior angles, and we know that they're going to equal each other. So I'm just going to scratch this out, and I'm going to try again. But this time I'm going to have measure angle 4 is equal to measure angle 5 thanks to alternate interior angles. Okay. So if measure angle 4 is 30, measure angle 5 is 5x plus 25. All I have to do is isolate the x. I'm going to do the opposite. I'm going to subtract 25 from both sides. And I'm left with 5 is equal to 5x. And then the 5 and the x are multiplying, so I'm going to do the opposite. I'm going to divide by 5, divide by 5. X is equal to, hey, 1. Well, okay then. Did I need to find out what x was in this problem? Yes, because down here it's asking, what is x? X happens to be 1 in this case. I know it doesn't say to find measure angle 5, but measure angle 5 is essentially 30 degrees because measure angle 4 is 30 degrees. And they're alternate interior angles, which means that they're equal to each other. Okay, looks like we just need to find measure angle 8 and we're home clear. All right. We know what measure angle 2 is. We know measure angle 2 is 30. And 2 and 8 are alternate exterior angles. Right? I hope so. Which means that measure angle 2 and measure angle 8 are the same. That's going to be 30 degrees. Alternate exterior angles. Another way we could have solved it is their vertical angles, right? We just figured out that measure angle 5 was 30 degrees. And if measure angle 5 is 30 degrees, measure angle 5 and measure angle 8 are diagonal to each other, which means that they're vertical angles, which means that they're equal to each other. So I could have used vertical angles. And I could have used angle addition postulate. We know measure angle 7 is 150 degrees. 150 plus measure angle 8 is going to equal 180. 180 minus 150 equals that, which means that is, I could have used the angle addition postulate. Whoops. There's a huge amount of ways I could have figured this out. And that's what you guys are going to be doing, okay? I'll upload another video if a lot of people are struggling with some of the problems, but feel free to shoot me an email if you are confused. I had a couple students shoot me a couple emails this week, and that's fine. As long as I am looking at my phone at the time, I should be able to look at the emails. So let me know whenever you're having trouble, and turn in all your stuff on time. Make sure you turn in your notes on time for this. Make sure you do the warm-up problems for each day, and make sure you turn in everything before due date. Don't let this pile up because, well, it piles up, okay? All right, that's all. Good luck.